in this one, okay, the Fourier series. Here why we are studying about this series format. Okay, so if some functions, okay, as it is in the form of the same functions format, we cannot send it to somebody, or we cannot utilize that in some purposes. Okay, for example, if you are look at this that meter, okay, so here, so this kind of that sine wave, you can check it, either it may be sine wave or cosine wave, or it's a combination of that sine and cosine wave. Okay, so it's in the medical process they are testing, even some mechanical test also, whether the stability test also they are going to use it. Okay, so but the basically the function is in the form of sine and function, cosine function, but the original function is what? Original input is what? Okay, if it is, we are going to check our the performance of our heart rate or something. Okay, if you are going to check it, okay, or the pulse, if you are going to check it, okay, this is the output of the function is in this form, combination of sine and cosine, but the input is different. So here we are going to express, some functions, namely the algebraic functions, exponential functions, even the trigonometric functions. Here we are going to convert in the form of this sine and cosine function. That series is called Fourier series. So for that, some basic things we needed. Okay, basic things we needed from our calculus part only. Not much. So here, okay, see here, orthogonal function means I'm going to integrate the two different functions. If that integral from this interval, if it is 0, then for that function is called orthogonal. For example, consider this function x square and consider this function x cube in this interval -1 to 1. So actually it is an odd function. So definitely this minus a to a format, it is 0. Is it clear? So this function x square and x cube will be orthogonal. Okay, and like that here it is x square and x to the power 4, even though it is an even functions, but here we are going to check, it is a non-zero case, so that we are going to say that it is a non-orthogonal. So even function, it is even function, definitely from this minus a to a format, so it is not going to provide the 0 value, so that here it is 0, so it is called orthogonal. Orthogonal means the integration of some particular interval, the product of two functions, okay, under this integral will gives us the 0 value, then these two functions are called orthogonal. Okay, and if you want to check, okay, graphic calculator, okay, so in this manner, suppose we cannot, here we restrict the interval. Okay, interval we have to restrict. Okay, x square and x cube, right? X square and x cube in your -1 to this -1 to 1. If you are integrating actually this portions, right, this -1 to up to this 1, if you are integrating this function, this is the function graph we are considering up to this, the area here, this is above and below, it may have some negative portion, maybe this negative portions will may have some extra value, we are comparing with this, okay, than this value, and this will be this negative value again will compensate with this positive portions value, then it will reach, it is 0 value. That's why we are calling it as the name of orthogonal. Orthogonal set means nothing but, so what are all the functions, this pi naught, pi 1, pi 2, which means that x square, x cube, like that, some functions here we are going to put it. Okay, that all those functions, when m and n are not same, means two different functions, every two set of functions if I am going to take, and we are integrating with this interval a comma b, then that functions are called, or this the set of all these functions is called orthogonal set. For example, 1 cos x cos 2x, 1 into cos x, if I am in 1 into cos nx, I am going to fix this one here, I'm going to fix this one here, Okay, but my pi naught function is here it is 1 into cos nx. Maybe my n, maybe here it is 1 comma 2 comma 3 4. Okay, this 1 with all these functions. Okay, all these functions. If you are computing from this minus pi to pi, since cosine is an even function, so here it is going to produce a 0. So this set is called an orthogonal set. This set is called an orthogonal set. Okay, so orthogonality, while we are using the sine function and the cosine functions over the interval on this minus L to this L interval, okay, minus L to L interval, cos mx pi x by L sin n pi x by L dx. Okay, if m and n are not same, this m and n are not same, and if m and n are same cases also, see m and n are, which means that cosine function same functions, cos square m pi x by L dx. If we are computing for this also, it is 0. That's the case m equals to n, not equal to n also. The same case here for cosine also. Actually here it is 1 plus 1 2 formula, here 1 plus 1 2 formula, and out of that it is combination of sine and cosine, where m and a can assume any positive integer values. This value is also 0. So this kind of sine and cosine, and as well as sine and sine, cosine and cosines are the orthogonal functions, are called the orthogonal functions. Is it clear? Sir, is it clear? At least one any
So can
Yes,
you
sir.
show?
yes ma. Ma, I will
So
share
can you
this
show this?
material, ma. You need, if you have any doubt, please raise the okay things, okay? Otherwise, say yes or something, okay?
Yes, sir.
Do you have any questions here?
No, sir.
Okay, ma. This material I will share at the end, okay? While I am solving the things, parallelly you write, and if you are, I made some mistakes, means you may correct me, okay? In the screen itself. Okay, don't separately write today, okay? Because I want to cover the thing. So now the periodic functions, it is a basic formula. We know that a function f of x we are having, for that a function f of x equals to f of the function x will be replaced by some number, say t, okay, or the period, okay, the period maybe p, if I'm using it, okay, any letter if I'm using it, okay, f of x plus t, if it is f of x for all x and for some p, okay, for some t, then this function f of x is called periodic functions, okay. And this least period is called the fundamental period. Least period is called the fundamental period. This is important. Fundamental period. If you look at the graph of the sine function, okay, my graph is not exactly mapped with, okay, this is a way, okay. If you are assuming that this point to this point is this 0 to 2 pi is period 2 pi, and this 2 pi to 4 pi also 2 pi gap, but here we are having that the fundamental period only, here we are assuming it, okay. Sir, is it clear?
Yes, sir.
So sin x has 2 pi 4 pi 6 pi are all the periods, but sin of x plus 2 pi x plus 4 pi x plus 2 pi will be same as with sin x. Okay, that's why the periods has 2 pi 4 pi and all. So the least period or the fundamental period 2 pi only, here we are going to assume. So sin nx and cos nx will have the period 2 pi. The same case cos x has period, what is that? It is 2 pi, right? It is 2 pi. This is how we are saying that it is 2 pi n, 2 pi by n. Sin nx, here I am going to add sin nx plus 2 pi nx plus 2 pi. So what will be the answer? Sin nx into
Can I?
sin 2 pi plus cos nx into cos 2 pi. So here if you are expanding it, okay, so here it is 0, here it is 1, Okay, only cos nx only I'm having. So this 2 pi is not possible. Okay, this 2 pi is not possible if I am writing in this way. Okay, but the same, if we are going to assume, this sine function n into x plus 2 by n or x plus nx plus 2 pi nx plus 2 pi, so that sine n of x plus 2 pi by n, will it works? Will it works? Will it works? Just check. Sine or nx plus 2 pi, this is nothing but actually in the form itself here we are having that this is function of x plus 2 pi by n. Is it right? From this just we take the n outside. Okay, so that sine n, this is like my x format, overall it is x format. Okay, so 2 pi pi n is the 2 pi pi n is the period of for my sine nx or cosine nx. Tan x has the period pi only. Tan x has the period pi only. So tan 2x, if you are asking again, here it is 2 pi, means that is divided by n. Here like that, pi divided by n. Any the constant has the number itself its period. The number itself its period. Okay, other examples for periodic functions, this is not only for the sine function, cosine function, tan function or constant function. Consider this, suppose this is a number some like -1 and this is 1 and this is 2 and this is 3. Okay, and here it is -1 and then here it is -2. Okay, these are all have the period 1. Am I right?
Yes, sir.
So this is the period which you have. Period means nothing but it is length of the interval, a minus 0. Okay, the same pattern here we are having either this part or this part. So the fundamental period only here we are assuming that it is a, and this function is f of x. The period. Okay, suppose this is 0 and this is up to a and this is up to b. So that the period. So my f of x may have this 0 less than x less than a. Suppose I am going to use x. Okay, and this a less than x less than b. Suppose this itself suppose some number, possibly it is 5. Okay, so this is 5. So period, if I want to consider, then this length of the interval b minus 0. So b is the period. So in this way the period can be calculated. Now to extend a function as Fourier series. Okay, this condition is important. Suppose I am going to assume a function f of x, that f of x, okay, defined except possibly and a finite number of this minus L to L. Okay, minus L to L. Sometimes this may be given in this way. Okay, small l also. Okay, small l also notations. It should be defined in this interval, and it is periodic. Okay, it is periodic with the period 2l, and f of x and f derivative of x are piecewise continuous. Piecewise continuous means my function should have some piecewise functions. Okay, piecewise functions. And then the series, okay, suppose I'm having the Fourier series. Okay, so it should be has finite number of maxima minima in one interval, and as well as the infinite number of discontinuity is not should come. Okay, only finite number of discontinuity should come in the interval. Okay, for example, if I'm going to use it, if I'm going to compute, is f of x can be expressed as Fourier series. F of x equals to the function. Suppose I am going to define this f of x equals to 1 divided by x minus 2 without defining any interval. Okay, as Fourier series. The question is the solutions. If I want to express the given function f of x equals to x minus 2 at x equals to 2, cannot be expressed as Fourier series. Why?
Discontinuous at x is equal to 2.
Yeah, it is discontinuous at, yes, it is discontinuous at x equals to 2. That's the thing. Okay, now the second problem is tan x can expressed as Fourier series. Here interval is not specified. If it is interval specified, then it is fine. Okay, the solution is no. Why? The answer is tan x.
Since tan x tends to infinity at x is equal to 90
Tan x
degrees.
is not having finite value, right? At pi. Is it clear? It reaches infinity. So there is no maxima and minima. Am I right?
Yes, sir.
Okay. R minus pi, no minima. So it should be has finite number of maxima minima. R and it is continuous. It should be defined and the value should be periodic. Yeah, it is periodic. It is periodic. It is periodic. But tan x having infinite value. Actually, it is infinite value at pi. It reaches to infinity. So these conditions are necessary only. Sufficient only, but not necessary. So if there's a function satisfying this kind of conditions, then this any functions can be expressed as Fourier series. So what is Fourier series? Okay, suppose I am going to assume an interval minus L to L. On this interval, the function is defined. On this interval, the function is defined, and outside of this interval, it is maintaining this periodicity, which means that suppose this is my function from a to 0 to a b, then the same interval whatever I am having this 0 to a, the same interval here it is b to c d, outside of this 0 to p, it is also going to maintain the same structure. So that's why it is called periodic. Is it clear?
Yes, sir.
Yes, sir.
Okay, outside of this interval. So f of x has the period. So what is a period? Length of the interval. So L minus of minus L. So L minus of minus L, which is 2L. Okay, this is my period. Okay, now this functions, if it is satisfied the Dirichlet conditions, then that functions can be expressed as the combinations of this cosine and sine. Okay, where n pi x by L and then this b sine n pi x by L. Or sometimes we may written this as f of x is a naught by 2. Individually these summations can be written 1 from into infinity an cos nx plus sigma n from 1 to infinity bn sin nx. Okay, sir. So this constants. Okay, here what is a naught in this series? A naught is here, it is given. So how to compute this a naught? Substitute n equals to 0 here. It is 1 by L minus L to L. This is f of x. Sir, here n is 0 means cos n pi x L by is what? It is cos 0 1, right?
Yes, sir.
So this formula, this Fourier's coefficient is nothing but it is Euler's formula. Computing this Fourier coefficients by these formulas are called Fourier coefficients. Fourier coefficients. Sir, is it clear how we are writing the Fourier series?
Yes, sir.
Okay, now just consider the Fourier series. Please remember, okay, for your understanding purpose only, I am just writing again. Okay, this is cos n pi x by L plus sigma n from 1 to infinity pn sin n pi x by L. F of x is where it is defined. F of x is, let f of x be continuous on interval. Suppose I am going to take it is C2 C plus 2L. C2 C plus 2L. The interval is, now it is C2 C plus 2L. So this form is called, we call it as L form. L means L may be number also. Okay, maybe number also. Okay, so consider this here A naught formula. A naught formula. Okay, so it is C2 C plus 2L. Before that, actually the formula is calculated by, it is 2 divided by length of the interval C plus 2L. C plus 2L. Actually, I need to subtract this. Okay, this 2 divided by C plus 2L minus C, this length of the interval, and then C2 C plus 2L f of x dx. So this will implies that here CC get cancels out, 2 divided by 2L, so that it is 1 by L C2 C plus 2L f of x ds. Sir, is it clear?
Yes.
Okay, now AN, the same format, 2 divided by C plus 2L minus C, C2 C plus 2L f of x. This whatever you are having assigned with this n, it is cosine function. The same function here we have to take it cos n by x by L into dx. This, okay, then Bn will be 2 divided by C plus 2 C plus 2L f of x. Can you tell me? So B, see here it's a Fourier series. Rewriting is, I'm just rewriting is the form of
Sir, your voice is
Sir, your
breaking a lot.
voice is breaking, sir.
I'm having an internet only I'm using. Now am I audible?
Yes, sir.
Okay, ma'am. So this minus L to L, just I'm considering C2 C plus 2L, C plus 2L. Here, suppose if C is minus L, then this interval is converted into minus L comma L. So the formula is alternatively here it is converted into minus L to L, minus L to L, minus L to L. Rest of the things are same. Is it clear?
Yes, sir.
Okay, now, okay, so here the important one is 4 types of formula you have to understand. Problem is very simple. The formula you have to choose properly. Okay, so here consider this. I will write. Okay, consider this. With this, I am going to derive two set of formulas. Okay, see, take here from 1. Okay, from equations number 1. Let C equals to 0. Series is same. What is A naught? AN, BN. Can you tell me? A naught is this 1 by L, 0 to 2L, f of x dx, right?
Yes, sir.
Okay, so this is f of x cos n pi x by L into dx. This is 1 by L. Okay, this is for your understanding purpose I gave it, and these are the formulas. Okay, so 1 by L 0 to L. I don't know why it is shrinking and again it is doing. Okay. Again from 1, let C equals to minus L f of x. What is your f? Bn, can you tell me? Just look at the
Minus L to L
f
f of x
L
sine of n pi x by L dx.
is 1 by L. All are same. Here it is n pi x by L into dx is, here it is fx. An means cosine, Bn means always sine. Okay, that's remember. Okay, it is same. Only the changes it is minus L to L, minus L to L, minus L to L. Is it clear?
Yes, sir.
Okay, Papa. So here it is given in minus L to L formula. This is only here it is given. Okay, outside of that, here suppose we are assuming that it is called pi form. It is called pi form. Okay, pi form. So let us take the Fourier series f of x be a naught by 2 plus sigma n from infinity.
Sir,
Yes.
sir, your screen is lagging, sir, and voice is also breaking.
What happened? Can you see my?
Sir, can you rejoin again, sir?
Okay. Students,
Yes, sir.
yes, now is it fine? Sir, here at in c comma c plus 2 pi, then the Fourier series going to have.
Sir, are you sharing something?
The screen is not visible, sir.
Now am I visible? Sorry, screen is visible.
No, sir.
No, sir.
Do any next meeting what we. I am ending this meeting.
I'm sorry, sir. Like, can you say
Sir,
again?
can
It's
you
completely
type in
understand.
chat box, sir, what you're telling now? Because we are unable to hear you. Your voice is
Yes,
breaking.
sir. Breaking a lot.
We cannot hear you, sir.
Chat in type in chat box, sir.
Am I audible?
Yes, sir. No,
Yes, sir.